In this video, we're diving into Amazon SageMaker AI, a powerful suite of tools from AWS that makes it easier to build, train, and deploy machine learning models at scale. Later on, we'll walk through a hands-on example using SageMaker data Wrangler to clean, transform, build, and deploy a model using the Titanic sample dataset. What is SageMaker? Amazon SageMaker is a fully managed service designed for developers and data scientists. It helps you through the entire machine learning workflow, from preparing data and training models to deploying them and making predictions, without needing to manage servers or infrastructure manually. Whether you're working on image recognition, predictive analytics, or natural language processing, SageMaker provides the building blocks. Core components of SageMaker. Let's look at the key components that make SageMaker so powerful. SageMaker Studio, a web-based IDE for ML. Think of it as your one-stop workspace for writing code, running notebooks, training models, and deploying them. SageMaker Canvas, a no-code interface for business analysts. You can build models using a visual interface without writing a single line of code. SageMaker Autopilot automatically builds and trains models based on your dataset. SageMaker Data Wrangler, a tool for data preparation and feature engineering with just a few clicks. SageMaker Jumpstart, pre-built solutions, models, and notebooks to help you get started fast. SageMaker Pipelines helps you automate and manage end-to-end ML workflows. How does SageMaker work? Here's how it typically flows. Data prep, you import and clean your data using Data Wrangler or directly from Amazon S3. Model building, use SageMaker Studio or Canvas to build and experiment with models. Training, run training jobs on managed infrastructure with the option to tune hyperparameters. Deployment, deploy your model as an endpoint for real-time predictions or batch jobs. Monitoring, track performance and retrain models as needed using SageMaker Model Monitor. Pricing overview and free tier tips. SageMaker pricing is based on usage. You pay for compute, storage, and specific services like training and hosting endpoints. But here's the good news. Free tier, great for beginners. AWS offers a SageMaker free tier that includes 250 hours per month of T2 Micro or T3 Micro notebook usage, 50 hours per month of training on MLT2 Medium or MLM4 Extra Large, 125 hours per month of hosting on MLT2 Medium. Tip: stick with small instance types like MLT2 Medium or MLT3 Medium for early experimentation. And shut down your notebook or endpoint when you're done to avoid unnecessary charges. Watch out for these. Idle endpoints still incur hourly costs. Large datasets in Data Wrangler or Canvas may require powerful and costly instances. Some features like AutoML, Autopilot, or Model Monitor might spin up large jobs behind the scenes. Monitor your usage. Use cases of SageMaker AI. SageMaker is used across industries and roles. Retail, predict customer churn, recommend products. Healthcare, diagnose diseases from medical images. Finance, detect fraud and assess credit risk. Manufacturing, predict equipment failure before it happens. Customer service, build chatbots and sentiment analysis tools. Whether you're a data scientist, a business analyst, or a developer new to ML, SageMaker makes it easier to bring AI into real-world applications. With this brief introduction, let's dive into the hands-on section. Welcome to this walkthrough of Amazon SageMaker Studio and Data Wrangler, where we'll explore how to prepare data, build a model, and generate predictions using Data Wrangler, all within a no-code interface. Amazon SageMaker is a powerful platform to build, train, and deploy machine learning models at scale. Before we dive in, a quick note: please do not follow along unless you're comfortable managing AWS resources. Running SageMaker workloads incurs real costs, and forgetting to shut down a notebook or endpoint could lead to an unexpected bill. Let's go through the SageMaker AI homepage first. Here, you'll notice two key setup options: Setup for Single User and Setup for Organization. The Setup for Single User option is ideal for individual developers or data scientists who want to quickly get started with SageMaker Studio. It provisions a personal studio environment with all the essential tools pre-configured. This is the fastest way to launch notebooks, train models, and manage resources without needing administrative setup. The Setup for Organization option is designed for administrators who want to set up SageMaker Studio for multiple users within a team or company. It allows for centralized control over user access, networking, storage, and security configurations, perfect for enterprise-scale machine learning environments. How it works section offers a quick snapshot of SageMaker's capabilities. Let's walk through a typical SageMaker workflow. Start by labeling your data or bringing in your own datasets. In the build step, connect to other AWS services and transform data in Amazon SageMaker notebooks. For training the model step, use Amazon SageMaker's algorithms and frameworks, or bring your own, for distributed training. Tune hyperparameters for optimal results. Deploy your model to a fully managed endpoint. And finally, monitor and retrain your model as needed for continuous improvement. New to SageMaker? Scroll down to watch the introductory video that walks you through SageMaker's full lifecycle, from development to deployment. Let's explore the left-hand menu, where each section is designed to help you build, train, and deploy machine learning models efficiently. Getting started, start here if you're new to SageMaker. This section provides onboarding guidance, setup options, and helpful tips to get up and running quickly. What's new? Stay updated with the latest features and announcements. This section highlights new capabilities and improvements within SageMaker AI. Applications and IDEs provides options for access development environments like SageMaker Studio, Canvas, RStudio, notebooks, and other integrated tools for building and experimenting with ML models. Admin configurations. Configure your SageMaker domain settings, manage user permissions, and customize how your organization accesses resources. SageMaker AI Dashboard allows you to return to the main overview. Use the search tool to quickly locate models, endpoints, or datasets across your SageMaker environment. Jumpstart offers pre-built solutions and models. Whether you need a foundation model, a computer vision tool, or a text classifier, this is the fastest way to launch it. Governance Options provides model dashboard and model cards. This section helps you apply security policies and audit your ML workflows. Hyperpod clusters manage and monitor high-performance, distributed training environments, ideal for scaling complex model training workloads. Ground Truth sections provides options to set up and manage data labeling workflows for supervised learning. Ground Truth enables you to generate high-quality labeled datasets at scale. Processing. Use this section to define and run data processing jobs, whether for cleaning, transforming, or analyzing datasets prior to training. Training. Launch and manage model training jobs. Specify training inputs, select algorithms, and also provide option for hyperparameter tuning jobs. Training plans. Organize repeatable training configurations. This section is perfect for automating training workflows across experiments or datasets. Inference. Provides all inference-related options such as models, endpoints, and an inference recommender. Augmented AI, A2I, integrate human review into ML workflows. Augmented AI lets you route predictions to human reviewers when confidence scores are low or business logic requires it. AWS Marketplace, browse and subscribe to third-party ML models and datasets. The marketplace connects you with solutions from trusted AWS partners. Let's now dive into using SageMaker AI in action. Let's begin by understanding the setup process. The Setup for Single User option is ideal for individual developers or data scientists who want to quickly get started with SageMaker Studio. It provisions a personal studio environment with all the essential tools pre-configured. This is the fastest way to launch notebooks, train models, and manage resources without needing administrative setup. Essentially, this creates what's known as a SageMaker domain, a prerequisite for using Studio or Canvas. For single-user setups, the domain configuration is minimal. It simply provisions the necessary permissions and enables internet access to support operations like data import and notebook execution. The Setup for Organization option is designed for administrators who want to set up SageMaker Studio for multiple users within a team or company. It allows for centralized control over user access, networking, storage, and security configurations, perfect for enterprise-scale machine learning environments. For organizations, the process includes defining user roles and access policies, typically managed via AWS IAM and Role Manager. Now let's click on Setup for Single User. As you can notice, SageMaker is being set up and setup is in progress. It takes a few minutes to configure a SageMaker domain and a Studio user profile. It is preparing SageMaker domain. It is configuring the resources needed by the domain. This is a one-time configuration and may take a few minutes. I'll resume when the setup is complete. As you can notice now, the SageMaker domain is ready. It has created the SageMaker domain. Now we can begin using Amazon SageMaker AI to build, train and deploy models. In this tutorial we will be using Amazon SageMaker Canvas and Data Wrangler to build a machine learning model and run batch predictions, without writing any code. We'll use the famous Titanic dataset to train a classification model that predicts passenger survival. Then we'll use a separate dataset, test records for Titanic classification, to make predictions on new passengers. Let's begin by launching SageMaker Studio from the left side menu. Click on Open Studio. If it's your first time, SageMaker will prompt you to set up a domain. As you noticed, I've already completed the single user setup, which provisions the required permissions and networking for services like Studio, Canvas, and Data Wrangler. Organizational users may configure additional IAM roles and access policies centrally. It opens a visual, code-free environment ideal for quickly building, analyzing, and deploying machine learning models. Let's take a quick tour of the left side menu in SageMaker Studio. The application section lets you launch tools like JupyterLab, RStudio, Canvas, Code Editor, and MLflow, depending on your workflow, whether you're coding, analyzing, or using no-code ML. Partner AI Apps includes integrations from AWS partners to extend your AI capabilities. Clicking on Home takes you back to the main dashboard. The Running Instances tab shows all your currently active compute resources. Under Compute, you can view and manage all your notebook and processing instances. The Data section provides access to Data Wrangler, Feature Store, and EMR clusters. Essentially, it lets you access and manage datasets linked to your projects. With AutoML, SageMaker helps you automatically build and train models without writing code. In experiments, you can track, organize, and compare machine learning runs. The Jobs section helps you monitor background tasks like training and transform jobs. Pipelines allows you to create automated ML workflows for repeatable processes. The Models tab is where you manage trained models ready for testing or deployment. With Jumpstart, you can explore pre-built solutions and foundation models to accelerate your work. Finally, the Deployment section is used to manage real-time endpoints and deployed models for inference. Now click on Data Wrangler on the left side under Data section. And launch Canvas. It is starting workspace instance for Canvas. Now we can start using Data Wrangler. Here's a quick look at how Data Wrangler works. Let's walk through the key steps in the process. Data Wrangler simplifies the entire data preparation process in SageMaker. It starts by allowing you to import data from a wide range of sources like Amazon S3, Amazon Athena, Snowflake, and over 50 other data connectors. Once your data is loaded, you can explore and prepare it using either a natural language interface or a user-friendly visual interface. This lets you perform complex transformations and analysis without writing code. After the data is ready, you can export it by creating reusable data pipelines powered by SageMaker processing jobs or integrating them into full workflows using SageMaker pipelines. Finally, you can take your prepared data and train custom machine learning models directly using AutoML, making the journey from raw data to model training faster and more seamless than ever. Let's click on Open in Canvas and wrangle some data. Import the Titanic dataset. Let's start by importing the Titanic training dataset from Amazon S3. Click on Tabular as the data is in CSV. As you can notice, Data Wrangler provides different data sources to import data from. Let's click on Amazon S3. Now I need to provide S3 endpoint. Let me get the S3 URI of the CSV file of a sample Titanic data that I have uploaded earlier on S3. Select the file and click on Next. Now we can get preview of the data. As you can notice, using the Import and Prepare option in SageMaker Canvas, we simply point to the S3 path and preview the data. This dataset includes several columns. Passenger ID is just a unique identifier. Class shows the passenger's travel class. Name, sex, and age are self-explanatory. SIB-SP means number of siblings or spouses on board. Part shows the number of parents or children on the ship. Ticket and fare are related to the booking. Cabin shows the cabin number, though it's often missing. Embark tells us where the passenger got on the ship. The target column is survived. It's a binary value. 0 means they did not survive. 1 means the passenger survived. We will remove the columns passenger ID, name, ticket, and cabin during pre-processing before model training, as these features do not contribute meaningfully to the prediction target and may introduce noise or negatively impact model performance. It also provides option of to do random sampling, which is very useful if we had a large dataset. But this dataset has around 850 records. So we don't really need to use random sampling. We can name the dataset something like Titanic_train. Click on Import. This is a diagram showing the flow of data. It also runs validation. Validation checks the quality and integrity of the data. It shows that there are no errors. We can run validation again after applying transformations. On the right side, we see several options. Get data insights finds data quality issues and gives suggestions. Chat for data prep uses generative AI to help explore and clean the data. Other options include combine data, create model, and export. Export lets you save the data or create a job. Let's click on Get Data Insights. Select the target column survived. For problem type, choose classification, because this is a classification task. For data size, keep the default sample dataset. Click Create. Canvas now displays the Data Quality and Insights report. It's quick and happens almost instantly. Canvas now shows the Data Quality and Insights report. The target column is survived and the problem type is classification. The dataset name is Titanic_train. CSV. Let's look at the summary. There are 12 features and 849 rows in total. About 7% of the data is missing. 90.6% of the records are valid. There are no duplicate rows. On the right, we see feature types. There are 7 numeric, 1 categorical, and 2 text features. There's also 1 binary feature. No datetime or unknown types. At the bottom, it says no high priority warnings were found. This means the dataset looks clean and ready for the next step. Now let's look at the feature summary. This section shows how useful each column is for predicting the target. The prediction power is scored between 0 and 1. Higher scores mean the feature is more helpful. Lower scores mean it adds little value on its own. We see columns like class, SIBSP, and sex have low prediction power. Each has a score under 0.05. Columns like cabin have a lot of missing values, over 77%. That's why it also shows a medium severity warning. No high severity warnings were found. At the bottom, there's a bar chart. It shows prediction power for each column. Features like name, ticket, and passenger ID have higher scores. But they may not be useful and could even cause data leakage. So, we'll be careful about which columns to include when building the model. Now let's check for duplicate rows. Canvas scanned all 849 rows in the dataset. It found no duplicates, which is a good sign. Note that vector type features are not included in this check. This means the dataset is clean in terms of duplicates. Now let's look at anomalous samples. Canvas uses an isolation forest algorithm to find rows that look unusual. Lower anomaly scores mean the sample is more likely to be an outlier. Higher scores suggest the sample is normal. Here, we see a few passengers with low anomaly scores. These rows may contain unusual values. For example, passenger 342 has 3 siblings and 2 parents on board. Passenger 120 is only 2 years old with 4 siblings and 2 parents. These cases may or may not be errors. Use domain knowledge to decide if the data needs fixing. It's a helpful step to spot odd patterns before training the model. Now let's review the target column, which is survived. There are 2 classes, 0 means not survived, and 1 means survived. All target values are 100% valid. There are no missing values in this column. On the right, we see a histogram. It shows that more people did not survive than those who did. This tells us the dataset is imbalanced, which may affect model training. Now let's look at the quick model results. Canvas trained a quick model using 80% of the data for training and 20% for validation. It used the XGBoost algorithm with default settings. The validation accuracy is 83.5%. ROCAUC is 85.4%, which shows good classification ability. Precision is high at 86.3%, but recall is lower at 67.7%. This means the model is good at avoiding false positives, but it misses some true positives. The training scores are higher, which may suggest some overfitting. For example, training accuracy is 93.7%. At the bottom, we see class-wise performance. For class 0, not survived, precision is 82.3% and recall is 93.3%. For class 1, survived, precision is higher at 86.2%, but recall drops to 67.6%. Overall, the model performs well, but there's room to improve recall for survivors. Now let's look at the confusion matrix for the validation set. The model correctly predicted 98 passengers who did not survive. It misclassified 7 of them as survivors. It also correctly identified 44 passengers who survived. but it missed 21 survivors, predicting they did not survive. This confirms what we saw earlier. Precision is high, but recall is lower, especially for the survivor class. Let's take another look at the feature summary. This table shows how helpful each column is for predicting survival. The column name has the highest prediction power at 0.26. Next are ticket and passenger ID, but these may not be useful for model training. They could cause data leakage. Age, fare, and class have lower prediction power, but are more reliable features. All features have 100% valid values, except ticket, which is valid for about 74% of rows. There are no missing values or warnings in this section. At the bottom, the bar chart shows prediction power visually. We'll use this insight to decide which features to keep or remove. Now let's look at the name column. It's a text feature with 100% valid values and no missing data. Its prediction power is 0.262, which is relatively high. The most common words found in names include Mr., Miss, and Mrs. The word Mr. appears in nearly 59% of names and has the highest predictive power. The word cloud on the right shows this visually. Larger and darker words, like Mr., have stronger predictive influence. No specific patterns were found beyond these word-level insights. Now let's review the ticket column. It's a numeric feature with 0% missing values. About 2.55% of the values are outliers. The ticket values range from 693 to over 3 million. There are 654 unique values in this column. The distribution is highly skewed, with a skew of 5.15 and kurtosis of 27.6. On the right, the chart shows how tickets are distributed and their relation to survival. The top plot shows survival rates across ticket groups. The bottom plot highlights the frequency of ticket values, with red bars showing the outliers. This tells us that ticket numbers vary a lot and may not follow a normal pattern. Now let's check the passenger ID column. It's a numeric feature with 100% valid values and no missing data. There are no outliers, and values range from 1 to 849. Its prediction power is 0.193, which is moderate. However, since it's just an ID, it likely doesn't help predict survival. It should be excluded during model training to avoid misleading results. The chart on the right shows a uniform distribution. The top plot shows how survival rates vary, but this is likely due to randomness. So, passenger ID is just an identifier, not a meaningful feature. Now let's review the age column. It's a numeric feature with 100% valid values and no missing data. There are no outliers, and values range from 0 to 80 years. The prediction power is 0.113, which is relatively low. This means age helps a bit in predicting survival, but not strongly on its own. The lower chart shows that most passengers were in their 20s. The upper chart shows survival rates. Very young and very old passengers had higher chances of survival. So, age may still be useful when combined with other features. Let's take a look at the fare column. It's a numeric feature with 100% valid data and no missing values. About 2.47% of the fares are outliers. The minimum fare is 0, and the maximum is 512. The average fare is around 30, and the prediction power is 0.0802. In the histogram below, most passengers paid lower fares. The red bars show where the outliers are. The top plot shows that passengers who paid higher fares had a higher chance of survival. So while prediction power is low, fare still carries some useful signal. Now let's look at the class column. It's a numeric feature that shows passenger class, first, second, or third. The data is 100% valid with no missing values and no outliers. The prediction power is 0.0495, which is low, but still useful. The chart shows that most passengers were in third class. The top graph shows survival rates by class. Survival was highest in first class, and lowest in third class. So, even with low prediction power, class is a meaningful feature. Now let's review the SIB-SP column. It shows the number of siblings or spouses a passenger had on board. It's a numeric feature with 100% valid data and no missing values. About 3.3% of the values are outliers. The prediction power is 0.0236, which is quite low. Most passengers had no siblings or spouses, as shown in the lower chart. The top chart shows that having one or two family members slightly increased the chance of survival. While not a strong predictor on its own, it may help when combined with other features. Now let's look at the sex column. It's a binary feature with values male and female. The data is 100% valid with no missing values. The prediction power is 0.0212, which is low. But the chart tells us something important. From the top plot, we see that females had a much higher survival rate than males, even though prediction power is low on paper. This feature is very important for classification. So, sex should be included in the model. Now let's check the parch column. It shows the number of parents or children a passenger had on board. The data is 100% valid with no missing values. The prediction power is 0.0142, which is quite low. Only 1.06% of values are outliers. Most passengers had no parents or children with them, as shown in the lower chart. The upper chart shows that having one or two family members slightly increased survival chances. So while parch isn't a strong predictor on its own, it may still help when used with other features like SIB-SP. Now let's explore the embarked column. It's a categorical feature that shows the port where a passenger boarded. The data is 99.8% valid, with just 0.24% missing values. The prediction power is 0.0142, which is very low. Most passengers boarded at port S, as seen in the lower chart. The top chart shows that survival rates don't vary much by port. So while embarked has little impact alone, it may still add context when used with other features. Now let's look at the cabin column. It's a text feature with a lot of missing values. 77.1% are missing. Only 22.9% of the values are valid. The prediction power is very low, just 0.0118. Also, Canvas flagged this column with a medium warning for ill-formatted data. About 12.4% of the values don't follow the expected pattern. The word cloud shows common cabin codes, but none of them seem helpful for prediction. Because of the high missing rate and low predictive power, this column is not very useful and may be dropped from the model. Let's quickly review the definitions section. It explains the types of features in the dataset. Numeric features are numbers like age or income. Categorical features have a limited set of values like port names or classes. Binary is a special case with only two values, like male and female. Text features include words or names. Datetime includes date and time information. Next are feature statistics. Prediction power shows how useful a feature is in predicting the target. Outliers are extreme values that fall outside the normal range. Skew shows if data is shifted to the left or right. Kurtosis shows if the distribution has heavy or light tails. Finally, for values. Valid values depend on the feature type. Missing or invalid values are not counted in the analysis. This section helps us understand the rules behind the data insights. Let's go over some key model evaluation metrics used in Data Wrangler. For regression models, common metrics include: our superscript 2 shows how well the model explains variation in the data. MSE, MAE, and RMSE measure how far predictions are from actual values. Lower is better. Median absolute error is another way to measure prediction accuracy. For classification models, we have: accuracy tells how many predictions are correct. Balanced accuracy adjusts for class imbalance. ROCAUC measures how well the model separates classes. 1 is perfect, 0.5 is random. Precision shows how many predicted positives are actually correct. Recall shows how many actual positives were captured by the model. F1 score balances precision and recall. These metrics help us understand how well the model is performing. Let's look at pattern learning. Canvas uses it to detect and describe the text format in your data. For example, digits 4 to 7 means a number with 4 to 7 digits. Alnum 5 means a string with exactly 5 letters or numbers. Canvas scans samples from your data to find these common patterns. This helps you catch errors or fix messy text. Here are some patterns it can detect. Alnum for alphanumeric strings. Digits for numbers. Upper, lower, or mixed for word casing. Whitespace for spaces or tabs. This helps ensure your text data is clean and consistent. Okay, that was helpful. Now we have our data analysis. Let's clean and transform the data using Data Wrangler. Let's go back to our data flow. You'll see the data quality and insights report here. Let's go back to data type and click on plus sign. Here, we have several options. We can add transformations. We can get data insights. We can use GenAI to prepare the data. We can also combine datasets. If we're ready, we can create a model directly from here. Or we can export the data to S3 or a Jupyter notebook and create a job to run later. Now let's start transforming the data. We'll use Generative AI to help clean and transform it. From our analysis, we know there are data issues we need to fix. You can ignore these, they're from an earlier practice session. On the right side, you can see the steps listed. Our data source is from S3, and the data types are shown here. We can change the data type if needed. Click on Add Transform. You can use over 300 built-in transformations without writing code. Or just type instructions using the Gen AI chat interface. For example, you can say, impute missing age values with the median. Or, convert sex column to binary values. You can also see a chart about each feature. It gives a quick view of how the data is distributed for that feature. Let's start with standard cleaning steps. First, remove duplicate rows. Let's view the generated code. It is calling drop duplicates function on the data frame. Let's click on Add Steps to add it to steps. Next, let's remove columns like passenger ID, name, and ticket. These don't affect whether someone survived or not. Let's check what Gen AI does in the background. It is calling drop function to drop the passenger ID, name, and ticket columns. We'll add this step from the Gen AI session. Now, remove the cabin column. It has too many missing values. Filling them could add noise or bias. Let's view the generated code and add it to our steps. Then, let's fill missing age values using the median. Again, we'll review what Gen AI does and add the step. Now, convert the sex column to numeric values. This helps the model understand it. Add it from the Gen AI session. Make sure the fair column is numeric. Let's add that step too. Finally, fix any outliers in the dataset. Check the Gen AI suggestion and add the step. Each of these steps is tracked in the data flow, so you always know what's been done. Now we have built a data wrangling flow. All the steps are lined up. These steps will be applied during data processing before building the model. Let's click on Data Flow to see the visual. You'll notice the data flow chart is forked. It shows the transformation steps we added. Now here, we can export the dataset. You can export to S3 to use it outside of Canvas, or send it to a Jupyter notebook for coding, or simply click Create Model, and Canvas will apply transformation on data to build the model. With that analysis of our model, let's go with the Quick Build option. As you notice, model is being created. It says that quick build usually takes about 2 to 15 minutes. I'll join when it is completed. And now, in just a few minutes, the model has been successfully generated. We're in the Analyze tab, where we can review the model's performance. At the top, we see the model accuracy, it's 82.35%. That means the model predicts survival correctly about 82% of the time. The F1 score is shown as 0.769, which measures how balanced the model is in precision and recall. Below, we see the column impact section. This shows which features had the most influence on the predictions. Class has the highest impact at 27.88%, followed by sex, age, and fair. On the right, we see a graph showing how different class values affect the prediction of survival. Each dot represents the impact of that feature on a single prediction. Let's click on the Scoring tab. This screen shows how well the model performed on the test data. On the left, we see a total of 170 predictions. The blue paths represent correct predictions, while the purple paths show the incorrect ones. On the right, we see model accuracy insights. When the model predicts 0, meaning not survived, it's correct 85.71% of the time. And for all the actual zeros in the dataset, the model also predicted 85.71% of them correctly. This visual gives us a clear picture of how accurately the model predicts both classes. Now, let's click on the Advanced Metrics tab. This gives us a deeper look at how the model performs. The selected positive class is 1, which means predicting survival. The F1 score is about 76.9%, showing a good balance between precision and recall. The model's accuracy is 82.35%. Precision is 76.92%. Recall is also 76.92%. And the AUCROC score is 0.832, which means the model is fairly good at separating the two classes. Below, the metrics table confirms precision and recall values as 0.769. These advanced metrics help you evaluate how well the model will perform on new data. Now we're ready to move on to prediction or deployment. Let's click on Create Model to start building a machine learning model that predicts survival. We also need to give the model a name. Let's call it Titanic Model. Now we choose the problem type. This is a predictive analysis problem using tabular data. We are not doing text classification or fine-tuning a foundation model. But it's good to know, SageMaker Canvas also supports those advanced options. For now, we just want to predict who survived. So, we select Survived as the target column. It's a binary classification problem, survived or not. Let's click Export and Create Model. Canvas now runs the data flow steps we built earlier. In a few seconds, it recommends the best model type for our data. Now we're in the build step of Canvas. You can see the full dataset with 849 rows. Each column is listed with its data type and feature type. Survived is marked as the target. Columns like sex and embarked are recognized as binary or categorical. Most columns are clean, no missing or mismatched values. Except for embarked, which has just 2 missing entries. You'll also notice that passenger ID, name, ticket, and cabin columns are no longer shown. These were removed earlier as part of the data transformation steps we applied. Now the data is clean and ready for training. We can click on Quick Build to start building our model. We also have option to preview model before building. Let's click on Preview Model. The estimated accuracy is 83.5%. This means the model predicts survived correctly about 83.5% of the time. We can also see the column impact, showing which features influence the prediction the most. Sex has the highest impact, followed by class, age, and fare. Other columns like embarked, SIB-SP, and parch have smaller effects. This gives us a quick idea of which features matter most in predicting survival. Let's click on Prediction. Now we're on the Predict Target Values page. By default, we're in the Batch Prediction tab, which lets us generate predictions for an entire dataset. You can choose between manual or automatic modes to configure the prediction settings. Below that, under the Prediction section, we can view all previous prediction jobs. Right now, no jobs have been created yet, so the list is empty. Once a job is run, this area will show details like the job name, dataset used, prediction type, configuration, number of rows, and status. This screen is where you'll return to manage and track all batch prediction jobs. Let's start by clicking on Manual. Now we need to select a dataset for predictions. Click on Create Dataset. Give a name to your tabular dataset. Then click Create. Next, we choose a data source. There are several options. Since my test records are stored in Amazon S3, I'll select Amazon S3. I already have the S3 page open. Let me copy the S3 URI for the file and paste it here. Then click Go. Select the file. And click on Preview Select. Click on Create Dataset. The dataset is now being created. Once it's ready, we can select it for batch prediction. Click on Generate Prediction. It's now generating the predictions. Now the predictions generation is complete. Click View. As you can see, it displays the prediction results for the dataset. Click Download to download the results. Now, let's compare the predictions with the original records. On the left, you can see the predictions I just downloaded. On the right is the original dataset, which includes the actual survived column. Note that I had removed the survived column earlier to create our test records. Here's what we found. Most of the predictions are accurate, except for 2, those for passenger ID 853 and passenger ID 855. As you can see, the model achieved around 95% accuracy, which is a strong result. Let's start by clicking on Deploy. We'll enter a name for the deployment and select the instance type. I'm choosing MLT2 Medium to keep the cost low. Now, click Deploy to begin the deployment process. It may take a few minutes, so I'll pause here and resume once it's complete. The deployment is now finished. Click on View Deployment. The status shows in service, which means it's ready. You can see the deployment URL here, along with sample Python code to call the endpoint. Next, let's switch to the Test Deployment tab. Here, we can test the endpoint directly. The sample input and prediction are already populated. Now, I'll enter my own test data and click Update Prediction. The prediction result is displayed here. It shows a 91.291% probability, indicating a high confidence prediction. Now, let's explore how to invoke this endpoint using the Python code provided. In this code, we're testing a deployed machine learning model using Amazon SageMaker runtime. We start by importing the Boto 3 library and creating a SageMaker runtime client. Next, we define our test input as a CSV string. It's important that the order of values exactly matches the model's training schema. We then invoke the endpoint by calling invoke_endpoint with three key parameters: the name of the deployed endpoint, the content type as text/CSV, and the input data. The response from SageMaker contains the model's prediction, which we decode from UTF-8. Finally, we print the prediction result to the console. This script allows you to quickly test predictions from your deployed model in SageMaker Canvas. Let's run the script. As you can see, we've received the prediction result by calling the model's endpoint using the input we provided. Now let's look into how to invoke the deployed SageMaker endpoint using the AWS CLI. Make sure you have set up your AWS CLI. We start by preparing our input data and saving it to a CSV file named input.csv. Then we run the AWS SageMaker runtime invoke endpoint command. We specify the endpoint name. The body flag points to our CSV file, and we set the content type to text/CSV. The output prediction is saved to output.csv. Once the command runs, we get a confirmation response showing the content type and the production variant that was used. This confirms that the request was successfully processed by the deployed model. As you can notice, the prediction result is saved to the output.csv file. Now, let's clean up the resources. First, delete the model's endpoint. Then, delete the model itself. Next, remove the model from Canvas. And finally, delete the associated data flow. In this video, we walk through using SageMaker Canvas with Data Wrangler to build a machine learning model, no coding needed. We start by importing the Titanic dataset from Amazon S3. Canvas lets us preview the data and automatically generates data insights, including missing values, duplicate records, and feature importance. Next, we clean and transform the data using the built-in Generative AI assistant, removing unnecessary columns, filling missing values, and converting text to numeric formats. Each transformation is tracked in a visual flow. Then, we build a classification model to predict survival, using the Quick Build option. In minutes, we get model accuracy, feature importance, and a confusion matrix. Finally, we run batch predictions on new data and export the results. We wrap up by shutting down the session to avoid extra charges. SageMaker Canvas makes the entire ML workflow intuitive, fast, and code-free.